So I'd like to welcome Dr. Jimmy Gutman. Welcome to Not on the Bead.
Thank you
So-
very much, Mark. It's absolutely my pleasure to be here.
For people who don't know about you, please just jump in and tell us your kind of history.
I think that I'm best known as an author on the topic of glutathione, a rather obscure little molecule that is really being unmasked and revealed over the last 20 years as to its tremendous potential to help us with our general health. So I've written a number of books, and if you allow me just to boast, this will be the last time I boast on the call. I've sold more books on glutathione than all the rest of the authors in the world put together. I don't know if that's a good thing or a bad thing. I'm sure my parents would wonder, what are you doing? You went into medicine and now you're focusing on one molecule. I can appreciate that, but before I got into this topic of glutathione, I was an academic physician. I was involved in teaching at the university. I ran residency programs. I put together many conferences. So I had a very active life in clinical medicine and in academic medicine. But this was a topic that I just found so compelling that I had to chase it down. And I spent the last 25 years looking at this molecule, glutathione.
Yeah. I mean, I admit myself, I hadn't even really heard of glutathione until about kind of 7 years ago. And my knowledge has been accelerating since then.
I'm not surprised. I'm not surprised. In fact, you may be surprised to hear that many doctors are only vaguely familiar with the term. But in the research community, I'll give your listeners a great tip here. There's a website called pubmed.gov. pubmed.gov. And this is the world's largest repository of research articles. So whenever anybody publishes an article, the vast majority of journals will post it on PubMed. And it's a tremendous resource for anybody who wants to look at cutting edge research. And really, it's the original research on which everybody is basing their opinions, whether it's a politician or a newspaper or a tabloid. You need to get to the truth. You need to go to your original research. So why do I bring this up? Is because on PubMed, if you were to put in the keyword glutathione, you would get back over 160,000 articles. Now, I need to put that in context. If you were to put vitamin C in there and vitamin E in there, the two of them together wouldn't add up to 160,000 articles. So there's actually been more written about glutathione and vitamin C and vitamin E put together. But there's a lag time between what shows up in these rather difficult to read research papers and our public awareness. So I'm not surprised, but soon, Mark, people are going to be using glutathione in their everyday English language the same way as we use the word antioxidant or cholesterol or these other terms that were obscure 30, 40 years ago.
Yeah. That's definitely happened with me since I kind of really started to understand a bit more. It's like when I ever meet anybody, it comes out, well, glutathione this, glutathione that, because it's just, it's a fascinating world. But going back 25 years ago, kind of tell us about that moment when you just, your interest became into glutathione, and what steered you specifically to become obsessed with it and let it take over your kind of career?
The grace of God, or just really good fortune, depending on what you believe in. I was sitting in my office when one of my patients burst in to the office, and said, Jimmy, I've come across something that is going to help us fight off cancer. It's good for Parkinson's, it's good for Alzheimer's, it's good for heart disease, it's good for lung disease, and no, 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 no. I said, whoa, it sounds like you're reading off of a can of snake oil. Come on. And his answer to me was a big thud on my desk. And what that thud was about 20 pounds of research articles. And he said, Gutman, go home and read these. Now, this patient also happened to be a former Golden Gloves boxing champion. So I decided it would be a good idea to listen to him. And what he managed to do by leaving me with this pile of research articles was absolutely ruin the next 3 months of my life, because I couldn't tear myself away from the articles. It was just crazy interesting and profound. I was canceling clinics. I was up all night reading about this stuff. And what I was reading about was glutathione. And what was even more astounding to me was that the major author appeared to be this professor who literally lived in my neighborhood, who worked at McGill University. So this same patient made an introduction. He put me together with this Dr. Gustavo Bunos, who was the co-discoverer of a product called Immunical, which raises glutathione. And I sat with him for 2 hours. And at that point in time, Mark, I said, this is too important for me to let pass by. I am changing my career. And I was doing well. And really some nice positions and security. But this was just, I had to do it because what I was reading about just seemed to have this spectacular potential. And so that was it. I was sold. I was sold.
The main question I was going to use for this podcast was kind of how can we protect ourselves in a pandemic? And of course, the main conversation is all to do with vaccines, and that's very political. And we know it's developed like cult-like beliefs in either for or against. So all of that aside, just push the vaccines completely aside. I'm fascinated with things we can do to help ourselves, and that's kind of where I discovered glutathione and how we've got in contact and everything. But can you just describe how glutathione works? Because I think everyone knows, we've all heard of vitamin C and D3 and vitamin E, like you said, but how does glutathione fit into the picture?
Well, if we look at glutathione and what it is, it's a rather simple molecule made up of 3 amino acids, and it already exists in every single cell of our body. So we all have glutathione in our body, except there's a constant taxation on glutathione levels. And this taxation comes from the aging process. It comes from physical exercise. It comes from stress. It comes from illness. It certainly comes from infectious disease. And it serves, its major role is to serve as an antioxidant. In fact, it's referred to as the master antioxidant. And why would we use a term like master antioxidant? Because all of the other antioxidants that you mentioned, and hundreds more, none of the antioxidants that we know of that we eat through our food stuff or supplements, none of them can work without the presence of glutathione. Because when vitamin C, for example, picks up a free radical, it's done its job, but its job is over. It's spent. So you have this vitamin C free radical complex, and then what happens? Well, everybody listening to this call has looked at the color of their urine after they've taken a vitamin C pill or multivitamin, and you're looking at gorgeous yellow or orange color. And what you're looking at is actually a vitamin C free radical complex that you're pissing out. So we lose, we would normally would lose um, these antioxidants very quickly, but there's a mechanism in place in our bodies whereby the vitamin C can be recycled so it can go back and do its work. And what the vitamin C is actually hands off um, these free radicals to a glutathione molecule and therefore liberates itself to go back and pick up another one. So all the antioxidants are being recycled because of glutathione, and glutathione is able to put these free radicals into a soluble state or a state that we can get rid of them out of our body, but at the expense of glutathione levels. So maintaining glutathione levels, you're going to get many, many more miles out of all of your antioxidants. And of course, antioxidants are also intimately related to the immune system. So the very early studies that we did at McGill University looked at um, glutathione levels in AIDS patients. I mean, we've been studying this for like over 40 years. And back in the 1980s, that was the plague. And AIDS came out, and everybody thought that would spell the end of the world. And when you had the diagnosis of HIV or AIDS in the 1980s, it was essentially a kiss of death.
Mhm.
Fortunately, these days we've done so much better. But we looked at this, and we found out, and it is not just at McGill, it was a great study at Stanford University in California. AIDS patients were, by definition, glutathione deficient, severely glutathione deficient. And not only were they missing glutathione, they were missing glutathione specifically in the white blood cells that went off track in AIDS, something called a CD4 lymphocyte. So, of course, we raised the question, what happens when you raise glutathione? Are you going to impact the outcome of these patients? And that was some of our first human studies. When we were studying this Immunical product, we had difficulty just doing a human study. You can't just decide to do a human study. You got to jump through a lot of hoops, regulatory and ethical boards. And this may sound terrible, but the ethics and regulatory people at the time, if you had AIDS, you had no prognosis. And they said, okay, these people are going to die anyway, so go ahead and play with your glutathione precursor. And we did. And with really good results, improved CD4 lymphocyte counts, decreased viral loads. Some of the patients were actually putting weight back on in this rather severe wasting disease. And that opened up the door for the research at McGill University. And then we became recognized. And that's one of the jumping off points where glutathione research really started taking off, the effect it had on the immune system. So, of course, we went from AIDS and we started looking at other infectious disease, hepatitis A, hepatitis B, hepatitis C. And so your question relates to yet another epidemic or pandemic situation. And because there's such a head start in glutathione research, glutathione has absolutely been investigated in COVID-19. Now, I hate to get political, so I will give you and your listeners a heads up. For most of what I say to you, Mark, and to your listeners, I'm basing it on science. Every once in a while, I'll digress and give you some of my own opinion, which is either speculative or we've all got our biases.
Hmm.
Raising glutathione, there's a very simple way to raise glutathione that we use in medicine, and that's a drug called NAC, N-acetylcysteine.
Mhm.
Um, there's no money to be made with N-acetylcysteine. So um, accessing research funds to work with N-acetylcysteine is not as easy as accessing research funds when it's being promoted by a multi-billion-dollar drug corporation. Okay, now this is totally non-scientific. This is just my free-floating thoughts. But if you look, go to PubMed. I gave you the address already.
Yeah.
Go to PubMed and enter COVID and glutathione, or COVID and N-acetylcysteine. You'll use up the paper in your printer if you were to print these up. You'll use up the paper in your printer. There's that much research. And what is clearly established, so now I'm going back to wearing my white coat. What's clearly established is acute COVID-19 patients have a glutathione deficiency.
Well, that is incredible information just on itself. I mean, one of the big questions I wanted to ask, just even backtracking from that, when you first said that the HIV patients were deficient in glutathione, how many other diseases do we see that pattern where glutathione, someone's suffering from an illness and their glutathione levels are low?
So here's where my credibility takes a hit if you first listen to me without following up on it. That guy who came bursting into my office and told me it's good for this, it's good for that, it's good for this, good for that, that reeks of charlatanism until you actually look at the research. The vast majority of major health challenges that face our population, including the aging process, is related to drops in glutathione. We lose about 10% of our glutathione every decade. And by losing glutathione levels, you open up the door to diseases of aging. What are diseases of aging? Cancer actually is one of the diseases of aging. For example, prostate cancer is clearly a disease of aging. Alzheimer's, Parkinson's, neurodegenerative disease, and on and on. So this is why it's such an exploding field, because we're finding this common final mechanism by which our cells and our tissues are being harmed. And that common mechanism is through the production of free radical damage or oxidative stress. And we found the master antioxidant. Let's put it to use.
So that is incredible information. So we're all kind of taking vitamin C tablets and trying to eat oranges, but our bodies actually have a way of recycling what we already have if we have enough glutathione.
Well, imagine what happens to us when we are deprived of good sustenance. I mean, we all know you can get something called scurvy from vitamin C deficiency, but that's extreme. That's extreme. Usually, it's much more subtle than that, and so the glutathione will act itself as an antioxidant, but also you're going to again get more miles out of your supplements and your fruits and vegetables if your glutathione levels are well, and your intake requirements will be lower because of that. But this is an important distinction that you brought up, Mark. There's something that we call endogenous antioxidants and something we call exogenous antioxidants. There's a handful of endogenous, which means from within, and the major endogenous antioxidant is glutathione. There are others, but really the one that counts the most, they're all important, but the one that counts the most, glutathione. Exogenous antioxidants are the things that you're going to find in supplements and in in your food stuff. Again, when I say food stuff, I mean plant-based, because only plants can make these antioxidants. I want you to ask why.
Well,
It's just, I'm sorry, I'm such a science nerd. Why do plants make antioxidants? Because plants are able to take energy from the sun, combine it with carbon dioxide, and make energy, usually in the form of a sugar or something like that. So they take sunlight, they take carbon, and they make sugar. That's simple, very, very broad strokes. The problem is the sunlight. Sunlight is radiation. Radiation is toxic. So plants have evolved to be able to absorb some of the radiation from sunlight and neutralize it through the production of antioxidants. And so we can eat these antioxidants and benefit by being able to protect ourselves from free radical damage. And sunlight and radiation, essentially what they are sources of free radicals. Just really cool.
plants are amazing. Plants are amazing. But my first question there is that if plants kind of worked out all that intelligence, why didn't mammals, or did we just invent hair to protect ourselves from the sun? Which is a problem for people like me, but
Well,
there's something wrong there in mammal biology, no?
yeah, but I don't know if the word is intelligent, but we're certainly mammals are pretty successful. And because not only can we eat plants and antioxidants, we can also eat many other things, including other mammals and other species. So the fact that we're omnivores make us very adaptable. So we're doing good.
And I guess we can move out the sunlight as well. That's the one thing that plants can't do. Plants need to have that kind of system within them because they can't move. They're stuck taking that kind of source of sun.
Yeah.
We can go in the shade. We can adapt, can't we?
Yes.
Yeah. Oh, absolutely fascinating. So we go back to, you mentioned scurvy there. So if you haven't we've known this name ever since we, set off sailing around the world with not enough sustenance for the sailors, and we've got kind of rickets for vitamin D deficiency. But what we don't have, do we have a word for glutathione deficiency?
Interesting. No, we don't. What generally happens with glutathione deficiency is that you will pick up other diseases, whether they're infectious or degenerative or otherwise. So glutathione deficiency can manifest itself as immune deficiency. Glutathione deficiency can manifest itself as a hyperinflammatory condition. So it's there. Wow, 500 ways for you to get sick because your glutathione levels are low. So no, I think there are one or two disease processes that are identified strictly as glutathione deficiency diseases, but we're all going to get sick before we reach that state.
So it's almost like you're saying, so the effects of glutathione deficiency is so wide, causing so many diseases. It's almost like that's maybe how it was hidden from us and why we're kind of quite late in science in terms of discovering the power of this molecule.
And it's not so much because of the glutathione deficiency, it's because we lack the protection to develop the protection against the development of these diseases.
Yeah. So, but something's caused the glutathione loss to cause those diseases, right? So, causing the loss is overuse. Is that what you kind of said before? If we're taxing our systems too heavily with toxins,
that's one way for sure, and that's one way. So we have to be very, very good at and our diet. We have to be very, very good at maintaining good sleep levels. Well, we have to be very good about exercise, which includes getting exercise, which also includes not getting too much exercise. Which glutathione levels will drop significantly in elite athletes. We've got some really great research projects going on now, where we have the compromised high-level athlete, whether they're professional or elite or Olympian, and they burn out. They get something called overtraining syndrome, which is rather complex, but always associated with glutathione deficiency.
Wow.
We get high-level athletes. I guess the big sport in your country would be football, or what we call here soccer. Soccer players, they can lose 10 or 20 pounds by the end of the season. And a lot of this is because of glutathione deficiency. And what we've shown is maintenance of muscle mass by providing glutathione precursors, so that this deterioration in performance over the long term is at least ameliorated. And so there are many Olympians and many professional athletes now that are learning this and taking advantage of this technology.
Wow. Wow. You mentioned the precursors there. Let's jump into those precursors, because I think you said there's 3 amino acids that make glutathione.
Yeah. So glutathione is made up of 3 amino acids: glycine, glutamic acid, and cysteine. 2 of those are really easy, Mark. If we were go to the corner restaurant and have any kind of a meal, we would get plenty of glycine and glutamic acid, but we won't be getting enough cysteine in a biologically available form. Cysteine is the limiting factor for your cells to make glutathione, which leads to a kind of tangential question: why don't we just eat glutathione? And you can find glutathione pills and powders and all that. Eating glutathione is not an efficient way of raising glutathione, because when you eat glutathione, it becomes rapidly broken down in your digestive system, and very little of it gets to your cells. And for the keeners listening to this, I'm sure there's some researchers and doctors that are going to tune in. Mostly it's due to an enzyme called GGT, gamma glutamyl transferase, which is uniquely high in the human intestine. Rodents have just a fraction of the GGT that we have in our guts, which is why you can feed a mouse or a rat glutathione and it'll raise your glutathione levels. You can't really feed a human being glutathione and expect any substantial increase. So what we need to do is provide biologically or bioactive available cysteine to the human organism, which can be absorbed, transported through the blood, taken to the cell, absorbed into the cell, and the cell starts to manufacture glutathione. And it's hard to do this. There are, of course, natural foods that provide us with biologically available or bioactive cysteine, but not so much anymore. When our grandparents, the ones that were fortunate enough to have a cow or a goat, and they would drink the raw milk coming out of that mammal, they would get some decent glutathione precursors. If they had chickens and ate the raw eggs, they would be getting glutathione precursors. If they killed the chicken and they killed the cow and they ate the meat, as long as it was almost raw, they'd be getting glutathione precursors. Now, you heard me say the word raw a whole bunch of times.
I picked up on that.
Yeah. So Vegetables, in order to get the precursors, cannot be boiled. They cannot be cooked. If you cook your eggs, it kind of destroys glutathione precursors. If you pasteurize your milk, it destroys the glutathione precursors because the cysteine has to be in a form, a biologically active form, which requires certain bonds to be intact. And heat will denature these proteins. Heat will break down these bonds and change the shape of these proteins so that they're not as efficient and they don't work as well. So it's harder and harder in our these days to get good produce that is going to raise glutathione. So then people look to supplementation, and there are really only a handful of very effective ways to supplement in order to reach improved glutathione levels on an effective daily level.
Right. Um, so yeah, what about you mentioned the gut breaks down glutathione with the what was it you said that was in our gut that the rats didn't have? I can't remember the name of it.
It's an
G,
enzyme called GGT, gamma
and
glutamal
then
transferase. That's the
GGT.
major enzyme that just kind of blows up glutathione. Yeah.
Okay, blows up. What happens if we take liposomal glutathione? If we go under the tongue and try and absorb it in for a different method, would that work?
Well, as you can imagine, I've looked at all of these, and I continue to have my ear to the ground, looking at ways of raising glutathione. Um, there may be a handful of articles that suggest that works. Most of the articles that I read, it doesn't work. And what we need to see are well done, double blind, placebo controlled, statistically relevant studies on human beings. Now, that doesn't mean one or two studies that may or may not have been funded by the makers of liposomal glutathione. It means third party objective researchers looking at this. And right now, the evidence is not strong. It's not strong. I'll change my mind when I say good studies. And there are one or two studies that I'm sure people are going to be sending you. I can already predict the two studies that they're going to send you because there's two studies. So it needs to be there. Research, a lot of research. You can't hang your hat on one or two studies. You need repeated confirmation and validation that what you're doing is working.
Exactly. And just before I ask you about the big precursor, what about if we did IV glutathione? Would that work if it's just literally glutathione is put in the bloodstream? Would it get to the cell?
Yeah. Intravenous glutathione works, except it suffers from a few drawbacks. Number one, it's expensive. Number two, there's obviously dangers involved with using an intravenous system. But on a pharmacological level, intravenous glutathione, the actual glutathione only lasts, the half-life is measured in minutes. Minutes.
Wow.
Just to give you an example, you'll find online, if you probably just Google intravenous glutathione and Parkinson's and ask for videos. It's spectacular stuff, and I know some of the researchers have done this. Guy gets wheeled into the clinic with Parkinson's, and he's in his chair, and gets an intravenous line, gets intravenous glutathione, stands up and walks stably across the room. Just beautiful, fantastic. The problem is, by the time he gets back home, he's in his baseline state because the intravenous glutathione is very, very short-lived. So then we either need to hang a bag up where he walks around with a pole all day, which is not going to happen, or we give him a glutathione delivery system that lasts a little bit of time.
Right. So if the body's got its own precursors there, then it can make glutathione on a more regular basis. So you're not worried about the half-life because it's
And
constantly making
yes,
glutathione.
yes, Mark. And it makes its own glutathione. You see, when you're injecting glutathione or eating glutathione or using liposomal glutathione, that's not your glutathione. That's not your glutathione. You want your own glutathione. You know you're going to respond well to it. It's natural. You know what that glutathione is that you're being fed with glutathione pills or liposomal glutathione or intravenous glutathione is. It is a 100% genetically modified substance. The place where this glutathione comes, you need to ask the right questions in science. Where does this glutathione come from? It comes from either a bacterial culture or a fungal culture that has been either irradiated, received clips and bits of DNA or RNA to change its genetic makeup so that this organism manufactures glutathione, which is then collected and shoved into your vein. So glutathione is a natural substance. Sorry, that's not natural. It may come from something that was alive. That doesn't make it natural. That's ridiculous.
So you're saying the bacteria wouldn't make the glutathione naturally, but it's been genetically modified to produce the glutathione?
Well, actually, the best way to start off is to find a bacteria that makes a bit of glutathione, or to find a fungus. There are certain fungi in the yeast family that make glutathione, and what you do is you amplify that effect
Right.
with gene splicing and irradiation. And so, yeah, you're better off starting with something that shows some promise and fussing with its genetic makeup so that you can provoke a response that you can modify and take advantage of.
Well, I'm shocked to hear that. And I think a lot of people watching will probably just be moving their kind of glutathione tablets further away from them right now as we speak. That's
right.
Yeah,
right.
When you look at the full, that's what knowledge is, and that's the research, is knowing the full story. You know, beforehand and afterhand. That's incredible. So that's you mentioned before, one of the main ways, and it's also very famous now. It's like a buzzword amongst everybody in these kind of COVID times, is NAC.
Oh yeah.
So NAC, does that solve everything?
NAC is it's a wonderful drug. It's a wonderful drug. I spent many years teaching and working in the emergency department. What do you call emergency? Do you call them emergency rooms in the UK?
A&E, accident and emergency.
Yeah. So that was actually my specialty, and NAC I used, and it is a life-saving drug. And I give you, for instance, again, there might be some terminology you might have to translate from American to British. Acetaminophen, I think you call it paracetamol.
Mm-hmm.
Tylenol, Adasol.
Paracetamol, yeah.
So
classic overdose drug.
Yeah, yes, and a very effective overdose. It's a good way to kill yourself. And so the way the paracetamol overdose works, it takes somewhere between 2 to 5 days to kill you. And the way it kills you is essentially your liver falls apart from oxidative stress. So I think it's a great thing that it takes 2 to 5 days to kill you. Now, why would I say something as shocking as that? Because most people, or many people that take an overdose, do so just, they're not really thinking they're in a fit or in a mood. They're just broken up with their spouse or whatever. And usually alcohol's involved too, which liberates your defenses, and so you down this whole big bottle of extra strength Tylenol, and you wake up the next morning with a freaking headache, despite all the Tylenol, but with the realization, oh my God, what have I done? Or somebody finds you and somehow you get over to the emergency department. So it takes 2 to 5 days to kill you. This is great because if I can get my hands on you in the first 24, 48 hours, I can save your life. And how do I save your life? I save your life with N-acetylcysteine. In the old days, we used to have you drink it, but along with charcoal, and it would make a hell of a mess because the NAC would make it nauseous and you'd be puking charcoal everywhere and everybody's clothes and shoes have to be thrown out. Now we use intravenous N-acetylcysteine. It's a little less messy. And we save your life. And so N-acetylcysteine is the medically recognized way of raising glutathione. Even if the doctors hanging a bag of N-acetylcysteine, he or she may not know that the way it works is by raising glutathione. This is what we do. So NAC is just a very effective, wonderful drug. And again, I say drug. Don't tell me it's a natural product because it's not. And we can look at where oral cysteine, L-cysteine, N-acetylcysteine, where it comes from. So N-acetylcysteine is life-saving. It's effective. People who use it can get it without prescription, even in health food stores, at much lower doses, of course. And it works. But Mark, it has some problems. It also has a short half-life, much longer than intravenous glutathione. NAC has a half-life, I guess it's roughly 4 hours. So when you take an NAC pill, you get this spike, but it's not going to last 24 hours. So even in the old days, in the emergency department, when we were using oral N-acetylcysteine, we would give it 3 or 4 times a day. And just to maintain therapeutic levels of glutathione. And NAC at effective doses for most people have a lot of gastrointestinal side effects: nausea, vomiting, diarrhea, cramps. And if you felt nauseous the first time you took your NAC, you'd feel 4 times as nauseous the 4th time you take it. So patients were not happy taking it, but I'd rather have a sick patient than a dead patient. But even at the lower doses of NAC that you will find in health food stores, a lot of people just don't tolerate it very well. Finally, also there are long-term consequences of taking this NAC, because why NAC? Why N-acetylcysteine? Why not just cysteine? Oral cysteine, when you eat it, also gets broken down pretty quickly. And by sticking this little side chain on the cysteine, which is an acetylated group, and acetylcysteine, you get the little side chain that protects it from being oxidized as quickly, so that it actually makes it to the cell. So how much N-acetylcysteine is protected by this acetyl group? This is interesting. And again, people just don't know this stuff. 15% of the cysteine is protected. So 85% of it becomes oxidized, and it's this oxidized cysteine that causes the side effects. So even by sparing 15%, the drug works. Now, I guess, Mark, N-acetylcysteine is something you can still get in the UK, and you can still get it here in North America, but there's a strong push by the powers that be to make N-acetylcysteine only available by prescription now. So is that the case? Have you heard that, Mark?
Yeah, and I know they're trying to ban it in New Zealand. Yeah, absolutely. There's a push. I'm not sure of the specific case in Britain, but we know they're.
Or if it happens,
we've seen with anything effective, but it's kind of almost like when you see the moves against it, you know it must be effective.
yeah. Well, I think even I believe it's Amazon that took it down off their website. I believe it's Amazon. I can't be sure again. So, so Mark, people are going to say, so where does the cysteine come from? Why are you calling it a drug? Isn't cysteine just an amino acid? Okay, where does the cysteine come from? 25 years ago, when you bought L-cysteine, isolated amino acid in capsule form, or it was added to your multivitamin or protein mix or whatever, 30 years ago, the cysteine came off the floors of Chinese barbershops. What? The major source of cysteine was from hair swept up of Chinese barbershops. And it was a lucrative business. First of all, a lot of hair there. And you take the hair, and the hair contains cysteine, and you'd put it through a number of biochemical stages, isolate the cysteine, and come up with cysteine. So the Jewish people who are kosher and the Islamic people who follow halal, not crazy about eating human stuff. I mean, cannibalism is frowned upon by most cultures. They came up with another method, and then the Chinese switched from hair to duck feathers.
Right.
So duck feathers is also a good source of cysteine. The Americans, not wanting to be outcompeted, Americans, as you know, are excellent business people, started doing the same with American chicken feathers. So when you're getting a cysteine supplement, this beautiful, oh, wow, I'm taking cysteine amino acid, you're taking a highly stepped on, biochemically derived essence of chicken feathers. So don't tell me it's natural. It's not natural.
And is that the same when they bond the acetyl compound onto the acetate to get the NAC? Is that cysteine?
Oh, it's a chemical process. Oh yeah, sure. It's a chemical process. I have nothing. Listen, I'm not saying that if something is chemical, it's bad, and something's natural, it's good. That's that splitting doesn't make any sense. Cocaine is natural. Arsenic is natural. Doesn't mean that they're good, and it doesn't mean that chemicals are bad for you. You need to look at the specific case and point. But don't tell me something is natural when you've done all that stuff to it and call it and put it on the shelves of a natural health food store. It doesn't make it natural.
And so it's not natural, but what's the kind of safety like on it with high doses? Can children take it? Pregnant women take it? NAC?
And acetylcysteine? Well, if we were faced with a child that came in with Tylenol overdose, we would clearly give N-acetylcysteine. But it doesn't mean that you should be doing that at home. I think with N-acetylcysteine, I believe, again, I'm not 100% sure. I'll always tell you when I'm not 100% sure. But I believe when you look up N-acetylcysteine in the American literature, it will tell you that it's contraindicated in pregnancy.
Right.
So it doesn't mean that it's not going to be used if somebody's clearly going to die from acetaminophen overdose, but there are other instances of using N-acetylcysteine. For example, before you get certain radiological dyes for an X-ray, often you will get N-acetylcysteine because these dyes can be kind of toxic to your kidneys, and so you're protected with the N-acetylcysteine. So there are other uses. But there's at least a relative contraindication for NAC in pregnant women. Yeah.
And you mentioned that long-term use wasn't good. I think I saw like one of your little talks where you said that after a couple of weeks, it becomes ineffective if you keep taking it consistently. Did I understand that right?
Yeah, because remember the 85% cysteine that becomes oxidized, you end up with a state called hypercystinemia. And hypercystinemia is strangely enough a pro-oxidant state. So what you started off doing, nobly trying to reduce oxidation, ends up after a while causing oxidation. It's kind of the same phenomenon we see with certain Parkinson's dopamine drugs. They work for a while and then they become counterproductive. So yeah, it is an issue long term.
But we say counterproductive. I mean, you're literally saying they become the opposite. They become oxidative. So they become.
They can.
It actually works. It starts working against what you're actually trying to achieve.
That can happen. Yeah.
Can happen. Wow.
Yeah.
Wow. So, yeah. So what about, you mentioned a product called Immunical.
Yeah.
Before.
Yeah.
Is that, so tell us a bit about that. Is that more natural way than NAC? Is that right?
Well, the key about the Immunical is that any steps taken to make it any different than the way it appears in nature diminishes its effectiveness. So the Immunical is a milk product. Now, I know we can get into the pros and cons of milk, and I'm not a big fan of milk myself, just because of the way it's produced and the way the cows are raised and all that. But if you have a good source of milk, in the milk, there are larger proteins, lactoferrin, for example, or lactalbumin, for example. These are large milk proteins that are high in bioavailable cysteine. And I'll get just a little technical, Mark. I don't want to lose too many people. What makes cysteine biologically active and what makes a protein biologically active is the shape of the protein. Now, the shape of these proteins are like a ball of wool, let's say, so that there are actually bonds between one strand of wool and another strand of wool. It's a cysteine to cysteine bond that when you take that ball of wool and denature it, in other words, change its shape, you unravel it,
right?
You tear apart these bonds. And the way to unravel it is either with severe mechanical agitation or with heating. Milk products, by law, need to be pasteurized. Pasteurization is heating. So by pasteurizing milk, you're effectively destroying some of the biological activity that it normally would have. So the Immunical is developed in a way where we can retain the native state, the natural state of these proteins so that these bonds are intact. And by doing so, when you eat these larger proteins, they're enveloped and protected from digestive processes and then taken to the bloodstream, taken to the cell, accepted by the cell, the cysteine gets into the cell and you make glutathione. So in the same way that the acetyl group protects the cysteine from 15% of oxidation, by being in a larger protein, we've got this shell around these active cysteine moieties that can be absorbed and utilized. So so it has to be natural. If it wasn't natural, it wouldn't work.
Yeah, and so that's naturally occurring. That protein shell is completely naturally occurring around the cysteine. That's how it is.
It is the natural shape, and constituents are what you will find in raw milk, except you need to get them out of the raw milk, and overheating it will kill it, agitating it will kill it. But you also, when you look at raw milk, it's not for everybody. Um, um, Lactose intolerance is really a big thing, especially in the United States. The further south you go, the more lactose intolerance you have because they're missing the genes for lactase. So we have to take the lactose out. We want to take the fat out. We want to remove all the toxins that show up in milk, whether they're environmental toxins or toxins that are secondary to the use of antibiotics, or God knows what else is being used in industrial farming. So yeah, it's a tricky process.
So this protein, this is a right to call it a whey protein.
Yes, it comes from whey, but the vast majority of whey is the byproduct of milk production, which means that it's been heated to the point where the whey is still wonderful nutrition, but not biologically active.
Right. So this is a whey protein made from raw milk.
Yes, it's and from specific herds. For example, when we receive a shipment, and it's only certain farms that will be supplying to us, we test it for toxins. We test it if, for example, if we found any traces of antibiotics, we would reject the entire load because it's exactly the opposite of what we're trying to get done here. So it's a huge financial disincentive for the farmers to cheat on how they're bringing up these cows, and you want them to be free range if at all possible. Depending on the climate that year, sometimes you do need to feed them additional things like corn if the fields aren't growing well that year. But it's a lot of effort. It's a lot of effort.
So with just going to products of Immunical being whey protein, why when I first came across it, first thing I did was check a lot of reviews. I was just looking around and I was exploring all these things. I checked a load of reviews, and there's all these other whey proteins. And people say, "Oh, that helped me as a bodybuilding thing. That helped me." When people reviewed Immunical, they're all talking about the health benefits. What is there a difference between Immunical and the other whey proteins? Easily available?
Most whey proteins, again, are byproducts of milk production.
Right.
Even if you go to some of those larger stores, retail stores, you'll find huge buckets of whey protein isolates, and they're mostly used or often used by muscle building enthusiasts. I think you need to be at the gym for about 3 months before you can even pick up one of these buckets. They're that big. And they'll cost you 10 pounds. It's good protein. It's good protein. It's good nutrition, but it will be devoid of glutathione precursors. Now, are there other companies that can come up with a way of keeping their protein undenatured, in other words, in its natural form? Well, technology can be stolen. Sweden can build a rocket ship to go to the moon because they can find the technology. But do they have the money and the resources and the time to do that? No. So there's a lot of expense involved in doing this properly, and even more expense in proving to the rest of the world that your product works. When you take your product and you publish study after study in reputable journals showing its effectiveness, not just in raising glutathione, but its clinical effectiveness, then you have a valid product. if you have a bucket of whey protein that you call undenatured and all that stuff, buyer beware. I don't know if it works. You would have to do a human study on it to be sure. And I guess doctors were a little bit more rigid in our acceptance of natural products. Not to say that natural products don't work. Many of them are wonderful. But we need an assurance that that particular product works. And the only way to do that is to test it. And so, yeah, it shows up. The Immunical actually shows up. There's two major publications, one in Canada and one in the United States. In the United States, you may have heard of it called a PDR, Physician's Desk Reference. And in there lists all the drugs that are allowed to be prescribed. And the Immunical actually shows up in that book. I think, is it the MMR? Is that what's the publication in the UK?
I don't know. I don't know. I've checked it years ago myself, and it used to be a big thick book like this before the internet.
That's right.
And used to whip way through, but I can't remember the precise name. But I remember searching.
We tried to get in there, but just, man, the amount of red tape, it just wasn't worth it yet. So
so that's incredible. A supplement in PDR.
Yeah.
It's kind of, so it's not a medicine, but it's recognized as one. It's not an official medicine, but it's been recognized as medical properties. Yeah.
Which is pros and its cons. The pro is it's a natural product and it's been validated. The con is, because it's a natural product, we're not allowed making any medical claims about it, and that is severe punishment in most countries. It's saying that a natural product that doesn't have a drug identification number does something for your health. So,
Well, I've, a bit of a spoiler alert. I've tried the product.
Oh, okay.
Not only have I tried the product, quite a lot of people that I know have now tried the product over the last 3 months, which is, how we kind of got together, because the results have been absolutely fantastic, been astonishing. We've had, probably one of my favorites was a friend of mine who thought it wasn't affecting her in any way for 3 weeks, and was even getting ready to tell me, "Oh, Mark, this doesn't work in certain ways." She was practicing the speech in her head. But then she went and had her full blood test done, and these blood tests have been done by the same lady for 20 years. And when she turned up for the blood tests, the lady wasn't there, and she came in apologising, all flustered. I'm late. But what happened is I got the test results, and when I looked at them, I figured they'd mixed up someone else's blood sample. So I ran back to double check, and it's the right one. What have you done?
Wow.
And that's numbers on paper and from a blood test, and even from a patient who was getting ready to tell me they hadn't noticed anything. So it's astonishing in its ability to work. But I know we've been on this chat for a long time, so I just wanted to kind of ask a few more questions just about this product, because there's two versions of Immunical. There's kind of the classic, the standard, which is just a pure whey protein, cysteine isolate, and then there's the platinum, which has got some extra little bits in. And when I first came across it, I saw the price difference, and I was, being a typical stingy Brit, I was like, "Oh, I don't need that," until I tried both. And I was like, "Okay, hang on."
Right.
There's these extras. What's the magic there? What's going on? What is the magic?
Platinum is Immunical with a couple other things added to it. One of the substances we've added is something that lowers your body's acidity in the form of citrates. And if you look at the association of having an acidic body with a number of different medical health problems, you'll realize that acidity is often not a good thing. Acidity also promotes the loss of certain minerals like calcium and magnesium, so that lowering acidity will also protect you to a certain degree against osteoporosis and things like that. But there are many, many associations, and I'm sure that your listeners will be able to draw links between this acid body and health problems. This is also really important if you're athletic, because athletes they're using up a lot more oxygen, a lot more oxidative stress, but they're also breaking down and forming things like lactic acid,
Mm.
which causes the soreness and all that. So there's a certain protection against even lactic acidosis. But interestingly enough, just the ingestion of proteins itself lowers acidity. So high ingestion of proteins leads to more acidity, which is one of the reasons why people with renal failure need to limit their protein intake. Just one of the reasons. So this is a good buffer. The other interesting substance that we've added to the platinum is a specific peptide. A peptide is a very, very small protein. This peptide also occurs naturally in milk. And the studies done on this specific peptide has revealed that it has natural anti-inflammatory properties. And again, the links between inflammation and a whole host of health issues is huge. Diabetes is an inflammatory issue. Heart disease is an inflammatory issue. Neurodegeneration, inflammation is part of the long chain of events that leads to the problem. So by lowering inflammation, you can blunt the effect of many disease processes, natural and otherwise. So it is a superior product. It will cost you a little bit more. I think that it's a great choice if you're an older individual, because inflammation is also something that gets higher with the aging process. It's a good choice if you've got a condition that's associated with inflammation. That doesn't just mean arthritis. Again, arthritis, heart disease, and neurodegenerative disease. So I think if you're over 45 years old, it would be a better choice. Or if you have a health challenge, or if you're an athlete. So you're going to recover from injury easier.
Easier, right. And what about pregnant women? Is the platinum good for someone pregnant if they've got that taxation on their body and they're breastfeeding?
Yeah. I'm very conservative with these things, and I would prefer a pregnant woman stick with the regular Immunical, because that's the one where we've done most of our studies. When I first started studying this, I was told that this whey protein isolate called Immunical was not to be used in pregnant women. So I asked Dr. Bunos, who was the discoverer, and said, Gus, why? He says, I don't know. Asked the other person, Dr. Patricia Kongshaden, which is one of the female pioneers in the immune system. Patricia, what's up with this? I don't know. I asked the lawyers.
Okay.
Pregnancy is such a risky condition. Anything goes bad, they're going to blame the last thing they put in their mouth. Yeah. Screw that. I'm going to look into this, and every bit of research that I found suggested that pregnant women should be raising their glutathione levels. And I've in my books, there's always a complete chapter on pregnancy and lactation, and with really dozens and dozens of articles to support that. And I haven't found any that showed an adverse effect using this strategy. So yeah.
Yeah, because I mean, just on just the basis, when I was just thinking about it myself, it's a product that's come from a lactating mammal to its newborn, so it should work. It should be beneficial. It's not looking like it's going to be.
It's on a cognitive basis that does make sense. Yes.
Yeah, just a very simple, very, very simple one. Yeah, that's absolutely brilliant. Well, is there any? more questions. I think you know, I think we could talk for another hour, another 2 hours about this, because it's just an absolutely fascinating subject. But we're kind of out of time now, and we've kind of got to, you know, a certain point. So maybe there's another time where I think I'm gonna get a lot of questions from a lot of people.
Okay.
I think maybe from
Okay.
doctors to, you know, everyone else. So maybe we
Sure.
could do something
Sure.
else in the future.
Sure.
And
Mark,
do
you're
some
really good. You're really good. You're just really good. I get interviewed a lot. You're really good. This was totally enjoyable. Thank you.
Okay,
Thank you.
well, I mean, it's just an absolute pleasure and honor. And just to say it again, you know, one of the things I love doing this is, you know, one day I'm kind of going, hang on, this is glutathione thing, and oh, there's this guy called Dr. Jimmy Gutman, who's obviously the guru, the hero of this, who's the leading person. I'm trying to find his books and trying to learn via the text. And then suddenly, next thing I know, somebody very kindly set up an interview between us, and it's given me the pleasure of talking to you firsthand. You've saved me a lot of. Well, I've got the reading to do, because those chapters on the lactated mammal, I can't wait to read all the more details before next time I come back, so I'll be better informed. But I just want to say, Jimmy, thank you so much for your time.
Thank you. Thank you, Mark.
Thank you so much.
Thank you.
In contact soon.
Take care.
Cheers.
Bye-bye.
Bye-bye.